Hello everyone, welcome back to our course on computer vision. I am Conceivably, your instructor, and today we are going to talk about scaling of images. So by the word you would have understood what scaling is. Scaling means reducing the size of the image or increasing the size of the image. So basically, why this concept is very important to understand, because whenever we increase the size of the image or decrease the image, we reduce the size of the pixels. Okay, and while doing so, suppose let's take an example. You have some image of 10 by 10 image you have, and it has got pixels of 2 by 2 pixels. Okay, now what you did, you enlarge the image to let's say 50 by 50. So what you did, so you increase the size of the image, so size of the pixels will also increase accordingly. So you have increased the size of the image by the ratio of 5. Pixel size will also increase by the ratio of 5. Now pixels have grown bigger. So how pixels are going to determine what colors that need to be filled in that big area. Right now 2 by 2 area was there and the RGB color index were filled over there and created the whole image. But now the pixels got bigger. Pixels became Pixels have become bigger. So now the colors that needs to be present also needs to be like predicted, like computer or our model or the program is gonna predict what colors should be present over there and how it is gonna predict it and what are the methods that we are gonna use to predict it. That is all come under scaling, and that is why scaling is important to determine how are we gonna basically scale up or scale down our image, or maybe in general term, in layman term, we call it resize our image. You would have listened this word along, like resize. So now to understand this method, let me take you to our notebook, Spider ID. There we will see how we gonna do this. Okay, so here we are. It's general the same thing. Just right now I've read this Linux logo image. I will show you what that image is. But first of all, understand. Let's come here. Let's first of all understand what are the concepts behind this scaling of images. So there is this one concept called interpolation concept, which we use on the resize method. So if you are from the maths background, you have did graduation from the maths, or maybe in some 12th class, you would have studied about interpolation. Now interpolation is like, you have got some values and like interpolation is like there's it's values between x and y, and okay, so x contains 1 and 2 and 3 and 4 and 5, and let's say 7 and 8 and let's say 10. Okay, same way the some kind of a values y will be having, like 10, and then there will be 20, 33. Okay, I filled out all the values. So you see, they are all like 10, 20, 30, 40, 50, 70, 80, 100. We have not taken here 6 and 9, and there's no 60 and 90. So these are like two values, x and y. There are two values. So interpolation, there are lots of methods inside the interpolation, and basically what is the task of interpolation is it judges these points and predict what should be the value of the 6, or what should be the value of a 9, or what should be the any value that comes after it, like 11, or let's say I want the value of 1.2, 1.3, 1.4. What will be their values? Right now this is linear, like 10, 20, 30, 40, 50, 60. It's going on, so it's very easy to find, but we don't get always a linear. So it's always, most of the time it will be non-linear, and it will be hard to predict. Like let's say here it is 22 and here it is like 39, and here will be like 47, here will be like 51, and here will be like 78. Now if it is like this, how are you gonna predict what is the value of 6? So for these there are lots of interpolation methods to predict these kinds of things. It all varies with the accuracy and with your conditions when they are going to work better and when not. Okay, so same way we are going to apply the interpolation method over here to predict what color or what RGB index should be present over there, how it is going to pick up the RGB index of that pixel. So um, basically there are like 4-5 kinds of interpolation, and one of them first is like default one, like interlinear. Then second one is inter nearest. Third one is inter area, and fourth one is inter cubic, and fifth one is inter Langsosfold. Let me write it. Langsosfold. Okay. So these are five interpolation methods that are most commonly used interpolation methods. Now, mostly in few of the previous videos, I have used the resize function method, and in that method, I won't use this interpolation. And when you are not using an interpolation method instead of a resize, then this interlinear method, this is a default method. It automatically applies on it. Okay. Then this is the nearest method. It picks out, by the word nearest, you would have understood. It picks out from the nearest what is the nearest pixels color that is being used, and it will use it. Then there is this area method. Okay, and this area method is basically very popular in when we are shrinking the image, means reducing the size of the image. This method is used, shrinking or reducing. Okay, we use this method. It is it's like more accurate method, but not in every conditions. Sometimes we use some kind of a size in which, or some kind of an image in which these doesn't work much properly. Then the another one is intercubic method. This is used, basically this is for zooming when we are increasing the size of an image. Okay, we are zooming the image. And then this fourth one is, it is also a lot more accurate, and we will see. I will just put out a one image, and I will use all of these five and show you how they're gonna work. Okay, what are the differences between them? You might not be able to see those differences very clearly because right now it's like running on my computer and you are seeing it on my computer, and it will reduce some kind of a pixel, and it also depends on what kind of a pixel you are watching the video. So you will not be able to see it properly, but I will try to make sure that you can understand it a lot more. Then this interpolation is one of the method, and there's another method called pyramid method that I will discuss after this interpolation method. Okay, so let's remove all of this stuff and let's come back to our program. Okay, so this is our program. This is one of our Linux logo.image, and let me show you what this image is. This is the image Linux. Okay, so now if we want to change the size of the image, let's create one more image, image 2, and we're gonna do cv2.resize. Now this resize takes the first argument, it is the source image. So our source image is image 1. Then it takes the destination size, but right now we are not giving it any size, so we will give it none. Now these are two values, fx, I'll just leave it destination. Now these are two values, fx and fy. It defines how much in the x-axis and how much in the y-axis you are increasing the image. So let's give it fx is equals to 1.5 and comma y-axis fy is equals to 1.5. Okay, then third one is, you can see last one is interpolation. So interpolation, now interpolation will be equals to cv2 dot Now I've told you all those interpolations here. Like first we will use inter. You can see here there are lots of interpolations have come: interlinear, intercubic, interarea, internearest, interlang, zosphere, interlinear, exact, intermax. So first we are gonna use interlinear. Okay. Let me break this from here. Yeah. Now you can see it. Okay. Then then let's say let's copy the same and control. Okay. Now this time we are gonna use interpolation. cv2 dot let's say area. Then we are gonna use interpolation nearest. After that cubic, and the last one is Langsdorff. Okay, so these are all our interpolation methods. Okay, now let's cv2 dot I'm sure make I'm sure over here after every image. So we're gonna write cv2 dot I'm show, and this one is linear. So we're gonna name linear to this frame and image 2. Okay. This one is area. We'll give it area name. Nearest. Cubic, and this will be Langsdorff. Okay, so we've got all these images. Okay, they will be shown. Original image already printing, and let's see what are the differences. Now these are all the images. You see original images over here, and we have increased the size somewhat. So you see these are all bigger than this original image. Either you talk about Langsdorff or you talk about linear, nearest, or there is this cubic. They're all like smaller than this image. Great, bigger than this image. Sorry. Now, if you see this image, this image looks a lot clearer. This original version of the image, it looks a lot clearer. But if you see this cubic image, it looks, see the boundaries of L over here. They're all like a little bit of blurred. You see the U over here in the bottom or over here. It's got little bit of blurry image because like there's a little bit a lot of a mixture of black and white, and you couldn't predict much better. Then we talk about this Langsdorff. Okay, you see it looks a lot clearer, but again same thing is over here with the L also, with I also. It is also a blurry image. Now if we talk about a linear, which is our default image. Okay, now you see this, it looks a lot more blurred image. You see here, see when you run this program in your computer, check out all the boundaries of these white and black boundaries, and you will see a lot of blurred things over here. Okay, same way in the nearest, you see in the nearest you will see this is like a most blurred image, I think. You see here, you can see it even here clearly that all of it is blurred right now. Then areas left. Area is also like somewhat linear, nearest, and it is completely blurred. And in all of these images, as I told you, when we are zooming the image, we are increasing the size of the image. Cubic will give you much better result, or Langsdorff will give you much better result than any other image. And that is what happened over here. This cubic and this is the Langsdorff over here. They are providing a much better result than any other image over here. Okay, even I would say Langsdorff is providing much better result than the cubic, and this is what you have to find out while scaling up or scaling down the images. That's why scaling is really important. Most of the people think, what is with the scaling? I mean, it's just normal stuff. You increase the size of the image, but you need to find out how you're gonna increase the size of the image so that you don't lose much of the information of that image, much of the detail of that image. You can preserve the details or the information of that image. And we can see here in Lanzoscope we are preserving a lot of the details. It is giving us much more accuracy than any other. Now same thing we can do is by reducing the size. But if I will reduce the size of this image, it will become a lot smaller. Then let me use Lena one here, Lena1.jpg, and I'm gonna make it 0.5 this time. Okay, I'm gonna reduce the size. Okay, so let's run it again. Let's see. Yeah, this is our original Lena over here, bigger image, and now these are all their smaller parts. No image, and here you see now in this colored image you won't be able to easily identify these kind of scaling, like, which is much more accurate. But when we are reducing the size of the image, you should prefer this area method. This is a good method, which preserves a lot of the detail of the image, and it gives you the accurate image out of these. Okay, so this is the reducing size of the image with all the interpolations. Now this is one method, interpolation. Now there is one more method in interpolation, and that is, okay, wait, get that place. This is a pyramid. Let me, pyramid method. Pyramid method. Okay, so what this method does is, it's a lot simpler than these interpolations. It works in its own and finds out the best way to increase the size of the image or decrease the size of the image. There is only one flaw in it that I will show you right now. Let's create the image 2 only. cv2 dot pyr. You see there are two methods, two functions, pyr down, pyr up. So let's take pyr up, and we'll give it image 1. Okay, now if we run it, wait a minute, I'm using this columns. Yeah, now it is this simple only, nothing much to do. And if I run this, I got, okay, I haven't shown that image. Let me cv2.im show, cv2.im show. pyr up, image 2, and if I run this setup program only, we've got these two images. And this is what the flaw inside of a pyramid method is. It increase the size, like, either if we are doing pyr up, it will double the size. If you are doing pyr down, it will reduce the size to half. So right now what it does, it doubles the size of this image. It increases it, like, suppose if it has a length of 10 by 10, so what it's gonna do is it will make it 20 by 20. So this is what happened over here in this image, but it will be a lot more clearer than used in any of the interpolation method. But it also, and you cannot be sure of this thing perfectly or completely, because it all varies with the kind of an image you are using, kind of variables you are providing it. Okay, it all varies with that. So you cannot be so sure that pyramid will always be better than interpolation. No, it sometimes interpolation will be better than pyramid, because you can see interpolation lots of features that there are lots of kind of interpolations, and so sometimes the one of the method of interpolation will be a lot better than the pyramid. So you need to always check with this things. So same thing we can do with a pyramid down image. Like right now, if I say make it pyr down, and it just reduces the size of the image. You can check it with a image logo also, that the Linux logo we were using, uh, capital L. Yep. Linux logo. Okay, let's run this F9, and now if we run it, oh, these two are the images, and you can see much and is a and this grain. I can't increase the size right now. I use a program to increase the size. Also, but if you see it, it is a lot clearer than of our interpolations. And even if you try EYR up, then you will get a good knowledge of it. Oh, it's not. Okay, I run the whole program. Okay, so this was our original image in the left hand side, and this is our PYR of image. And you see, they are less blurry. This images. It is a lot less blurred than any of our interpolations. Even if you try it with Langsos 4, it is much more accurate and much more, you know, finish. Not basically not will be equal to this original one, but yeah, better than any of those interpolations. So it is working fine over here, but maybe not work with the image that you will use. Maybe in that your interpolation image is better. It resize the image better. So this is all about interpolation and scaling and pyramid methods. So try it out, try it with the images, change these effects and advice, and sometimes put the remove the effects and advice, put some values, pixels over here, pixel values over here for which size you want to put it. Like Lena one is 512 by 512. You can make it like 700 by 700, and work out with these interpolation methods and try to work with this and find out which kind of method works better in which kind of conditions. Okay, so this is all in this, so see you in the next video.